So hello everyone, as you know I haven't posted any video on my channel from the last 4 days, but from now onwards I'll be consistent because I was traveling and that's why it was not possible to make videos. So I'll be consistent from now onwards, and I have decided to make videos on topic by topic. Like firstly I am gonna pick linked list because it's my favorite data structure, so I am gonna firstly pick linked list. After that I will be discussing stack, all stack related question. After that I will be discussing binary tree or tree, you can say broadly terms, and after that I will discuss graph questions. After completing these 4 data structures I will jump to recursion. And then DP, dynamic programming. It's a nightmare for programmers. Dynamic programming. Okay, so that's how we are gonna work. In this video let us discuss a easy question of linked list. Okay, first question of linked list: finding middle element. Now let me explain you the question. I am given with a linked list, and I have to find the middle element. So you can see in this linked list the middle element is here. Okay, so I have to return this. Now what is in the case of even size linked list? Say this is a linked list of even size or even number of nodes. In this case my middle element will be this. As you can see, there are 2 candidates who can be the middle element, so I will return this node as my middle element. So let's see how I'm going to do this. I will be using a very famous algorithm which is known as a rabbit and tortoise algorithm or fast and slow algorithm. Let's name it fast and slow. Okay, what I am gonna do in this algorithm is I will say this is my head node. Okay, so I will make 2 pointer. One will be my F means fast, and second will be my second or slow, not second but slow. Okay, so now let's discuss one thing, how these 2 pointers gonna move. My slow pointer will move only 1 node ahead. Okay, as this is a singly linked list, you can only move towards one direction, and my slow pointer will only move to 1 node at a time. But my fast will move to 2 nodes on the same iteration. Okay, means on a same iteration my slow node or my slow pointer will move only 1 node ahead, but my fast pointer is gonna move 2 node ahead. Okay, so let's visualize this, how this algorithm is gonna work. Let me take the eraser and let me erase this. Okay, now what I am gonna do is I have to move slow pointer by 1 node. So say this is my slow and this is my fast. After 1 iteration my slow will point to this, and my fast will jump from here. It will not stop here, it will go here. So my fast will be here after first iteration. Let me erase all these elements. So my fast will be here. Okay, now after first iteration, in second iteration my slow will move here, and my fast will jump to here. It's here. Okay, oh sorry, I have erased accidentally the slow pointer. So my slow is here and fast is here. Now I will check for the condition. Like here I am standing here and there is nothing. If I look forward to it, there is nothing, there is a nothing, null. Okay, so what I will do, I will simply return slow until and unless I encounter a situation where my fast dot next or fast dot next, as here I am moving 2 nodes ahead, so I have to keep an eye on the next node and the next node, because if I point somehow my pointer to the next node, my algorithm or my set of code will give me error. So what I will do, I will simply keep an eye on these 2 things. If my fast dot next is null, is null, or my fast dot, not or, it will be and, my fast dot next equals to null. If any of the two is null, then my loop will break out and I will return my slow pointer. Okay, I will return my slow pointer or the value at slow pointer. I hope this is clear. So now take the case of even size linked list. Let us take a linked list which is having even number of nodes, 1 2 3 4 5 6. Okay, perfectly done. Now I am gonna pick 2 pointers here. One will be my slow and other one will be my fast. As I know, I have to move slow by 1 pointer and fast by 2 pointers. So what will I do? I will simply, after first iteration, my slow will move to here and my fast will move to here. Now let's erase the older notations so you guys may not get confused. After first iteration, my slow is here, fast is here. Now after second iteration, my slow will move to here. It will move one step by here, slow. Okay, and my fast will move from here to here, because fast is moving by 2 steps, so fast is ahead of slow. Let's erase the older notation so you guys might not get confused. And here I can see I am keeping my eye on 2 things. I am keeping if fast dot next is equals to null, which here stand false because my fast dot next is not null. But if my fast dot next equals to null, then I have to return the slow. In this case, you can completely see like fast dot next is null. So in this case, do I need to or do I have to return slow? No, I don't have to return simply slow. See, slow is here, and in older example I told you if there is an even size linked list, I have to return this element. So what will I do? I will simply break out from the loop. I will move slow pointer by 1 step ahead. So I will move slow pointer by 1 step ahead, then my slow will point to this element, and then I will return slow. Like I will write one more line here, slow equals to slow dot next, and then I will return slow. So this was my intuition. Let me recap so that it will be better for you. What I am gonna do here, if this is my linked list, I'm not gonna separately explain or recap the examples of odd and even. You can check that on the video, like by watching all the video. I will take 2 pointers. One will be my slow and other one will be my fast. You have to move slow pointer by 2x speed or 2 node speed, and slow pointer by 1x or 1. By this speed, the fast will move from here to here. Okay, as it's a even size link, so I will check for next, that's another story. And my slow will move from here to here. Okay, now I will look, in the case of even size linked list, I will look for fast dot next which is null here. So what I will do, I will simply move slow pointer 1 step ahead and return this element. Okay, and in the case of odd size linked list, it will be like this, 1 2 3 4 5. Okay, my slow is here, let's call it S, and fast is here. My fast will move 2 index ahead, so it will go directly here, and my slow will move only 1 index, so it will move here. In second iteration, my fast will jump from here to here, it will on the last node, and my slow will jump here, so I simply have to return this. Okay, so let's directly jump on the code and let us see what we have there to learn. So this is my code. I hope it is visible to you guys. What I am doing here is I am making 2 pointers. Let me zoom this. Okay, what actually I am doing here is I am having a head node. Okay, so I am having a head node. I am making two pointers, one is fast, another one is slow, and both are pointing to head. Now I am running a while loop, okay, and I am checking for conditions. Let me highlight this. I am checking for condition fast dot next not equals to null, and fast dot next is also not equals to null. Means I have to keep an eye on two things, my fast dot next and my fast dot next. Okay, so if this condition stands true, what I will do, I will simply move slow pointer by one step or by one node, and I will move fast by two nodes. Now if the linked list is of even size, then that case will arise when my fast dot next will not be equal to null, but my fast dot next will equals to null. In that case, what I will do, I will simply move my slow pointer by one index. So I will move my slow pointer by one index. Here I am moving it. It only will be done in that case when my fast dot next is not equals to null. Means it will be executed in that case only when my fast pointer is not standing at the last element. So see you all in the next video, and I will be discussing all the questions of linked list which will be asked or which you have seen are mostly asked in DSA interviews. So till then, bye and take care, bros.